In a previous video, we saw an overview of dictionaries in Python. Now, in this video, we're going to take a hands-on look at how to create a dictionary, and then how to create a data frame out of it, and then some of the advantages that we'll get with the data frame, like the ability to add an index, and how to add columns and rows. So let's jump right in. I've started by importing our two standard imports, and now I've just pasted in a little bit from that previous overview presentation, where we're creating a dictionary for a redbud. And you see here we have genus, species, common, max height, edible, and then edible again. Well, we know that values within a dictionary have to be unique, so we know it's not going to end up with both edibles. But let's take a look at what we get. So we get genus Ursus, species Canadensis, common eastern redbud, max height 25, and edible is false. So effectively, the last row of the duplicate ended up overwriting the first row, and we ended up with a value of false. Now, if we take a look at this, this kind of looks JSON-like. The format that we have here is somewhat JSON-like, where we have curlies and then name-value pairs separated by commas, and the name and the value themselves separated by colons. So let's dig into this a little bit more. What happens if we try to print a single item from our dictionary? First of all, we use the print command, and then we'll refer to the dictionary variable name, which is redbud. And just like a data frame, when we want to reference a single field, we'll put it in square brackets and then the name of the field in single quotes. And you see that it was able to dig down and find Eastern Redbud as the common name from this dictionary. Now, let's take a look at how many elements are in the dictionary. And 5 elements, once again, not a big surprise if you count. You'll see there are actually 6, but one's a duplicate, and so those will get consolidated into 1. So that gives us a total of 5. Now, let's consider a different dictionary that we're going to create. Perhaps I want to take height measurements of trees over time. So just as I have before, I have the variable name, which is height, and then the assignment operator, which is the equals, and then open curly, close curly, to indicate that we're going to have a dictionary. Inside of the dictionary, I have the key, and then a colon, and then the value. But this time, unlike the one above, where I'm storing a single value with each key, this time I want to store multiple values, and those are going to be the height measurements over a series of years. And we know that there are likely going to be more years in the future, so we'll likely need to append more data to this. So let's just start with our redbud. Note I'm using decimals to indicate this will be a floating point value. But look at closely what we have here. We have redbud, and then a colon, and then a square bracket, and close square bracket in a series of comma-separated values between those two. So in this case, the key is redbud, but the value is a list of measurements. So value is a list. Now I could put a comma after that, and I can go ahead and fill in the details for Paul, and Apple as well, just like so. Now, when we're creating one of these, it's a good idea to have the same amount of elements in each list. That'll have it map to our data frame a little bit easier. So we're assuming that we're starting all of these measurements at a certain time. But if you take a look here, each of the lists has the same number of values. And coming out once again, looks somewhat JSON-like, but nonetheless you get the idea. We have the curly, and then the key and the value, where the value is a list, and then a comma, and then key value, key and value separated by colon. Let's take a look at some types here. What if we say, what is the type of the redbud element of the height dictionary? Not a big surprise, it's a list. And keep in mind that we're walking from height to redbud, and then when we're asking for type, we're asking for the type of its value in that key value pair, and this is a list. But the neat thing is we can dig down to an individual value just as we would any other list. So remember, we're pointing effectively to what's highlighted here. Now, if I say element number 0, I'm accessing the very first element within that list, and we see that it is a float. As a matter of fact, I could print out just that element if we want, like so. So starting with the variable, going to the key, and then the list element number. Now let's create a data frame out of it where we can add an index. Luckily, one option we have is to simply pass a dictionary to the constructor of DataFrame, and you see it will create one and give us that nice look and feel. One footnote, though, is that right now the indexes or the indices don't make a whole lot of sense because it's numerical starting with 0. And we know these are likely going to be annual measurements. So let's make an index and associate it with this data frame. So notice there's an index attribute on DataFrame, and we can simply pass it a list. One more note, one additional reinforced note really is that make sure that the list matches the number of rows that we have so we have a nice secure fit. Now for that index property, we can also give it a name, which in this case I'm saying measurement year. And you see now instead of 0, 1, 2, 3, we have measurement year as a title, and then each of our values is the row index. And now we can use this row index for things like slicing the data, selecting the data, and really just having that human readable index makes it more appealing, more readable. But what if next year comes and we need to add some more measurements to this table? How can we append some rows to this table? Let's try that out. As a matter of fact, I'm going to try to add 2 rows at once. So in this case, you see we've basically just repeated what we did above. We make a new dictionary, this time with 3 elements. Each element has a list, and each list has 2 measurements in it. We take this dictionary, we pass it into a new data frame. We add an index to the data frame, and because I'm doing this by hand, I'm making sure that the index is unique compared to the other indices that we already have. And then I give it the same name, measurement year, and print it out, and we see that we basically have the 2 rows we want to add up here. So to add them together, we can use a feature in Pandas called concat. You see with PD concat, we pass in our original data frame and the new data frame, and we're assigning the result of this operation to our original frame. So we're effectively overwriting that original data frame with the new combined data frame. Now we have a couple of parameters we can pass in here about, are we going to sort things, are we going to use the index or ignore the index? And after all is said and done, we see, okay, good. We now have our 3 existing trees, and we have all the measurements from 2020 all the way through 2025. Now, what if we want to add a column? Maybe we planted some new trees, or we observed new trees, or maybe we have 2 data sets of tree measurements and we want to merge them together. There are a couple ways to do it. If we want to add a column one at a time, it's actually fairly straightforward. We just specify the column name and then assign values to it. If we want to specify more than one column, we have to do a little bit of looping. So let's explore both options. First, let's say I want to start adding magnolia measurements to my data frame. I'll start by just saying df, name my data frame, and then make a new column called magnolia. The column does not yet exist, and then I simply use the assignment operator, and then I pass in the values that I want to align with magnolia. And we see, sure enough, we now have our new table with our magnolia measurements. Now, let's add a cherry and a pear. I'm going to add this from a dictionary, and I'm going to use looping or iteration to iterate over the dictionary and then add the values to our table. So we start with the dictionary. So you see we have a dictionary. Now let's start a loop. So new trees items is going to return to us the cherry and the pear, but it's going to return it to us in 2 pieces, a key and a value. So when we call new trees items, we know that that will be key, comma, value. So for each item, the key, cherry, the value of the list, the key, pear, the value of the list. Now we can wrap this in a for loop by saying for key value in new trees items. So that means let's shake hands with everything that new trees.items returns, which is going to be a list of each of its elements. Let's shake hands with each of those, and then as we're shaking hands with it, let's ask for the value, which is going to be that list. So let's take the key and make a new column out of it. Let's take the list of values and make those effectively the entries for each of the rows that intersect with that new column. So colon means, okay, we're starting our loop, and then in the land of Python, the body of the loop is simply what's indented. We don't need curlies or anything like that. So I'm going to say data frame key equals value. So just like we did up above with data frame magnolia, Here on the first iteration, we're going to say DataFrame cherry equals these measurements. On the second iteration, we're going to say DataFrame pair equals these elements. And when it's all done, we should have a data frame with the redbud, pawpaw, apple, magnolia, and our 2 new columns. And there we go. Redbud, pawpaw, apple, magnolia, cherry, pear. And we see that the values align well, 6, 7.1, 8.3, 6, 7.1, and 8.3. So that's a look at dictionaries in Python hands-on and how we can convert dictionaries to data frames, how we can add an index to a data frame, how we can add rows and columns to a data frame. This is a very important part of data mining for business intelligence because the vast majority of our time is going to be analyzing data before we run it through a model or before we model the data. And even cleaning up the data will be important. So in the next video, we're going to take a look at some operations we can do on our completed data set. Things like max, things like filtering, and a whole lot more that this now opens up for it. I look forward to reading your comments. Thank you.